Hi, this screencast is about the structure of the atom and what particles will be in the atom and where they will be and how you can figure out how many for each element. Alright, so the structure of the atom is the smallest particle of an element that retains the chemical properties of the element, meaning if you break it down any further, it no longer has the properties of the elements listed on the periodic table. There are particles within the atom, and they can be identified here as the ones I'm going to talk about. So the nucleus is the small region located at the center of the atom, and the nucleus is made up of at least one positively charged particle called a proton, and usually one or more neutrons. They are neutral in the nucleus. So the nucleus has two things, protons and neutrons. The number of protons is dependent on which element you have, and the number of neutrons, you can determine that from the mass. Alright, surrounding the nucleus is an area called the electron cloud. It could be referenced as the orbits, it could be referenced as the energy levels, and they all have negatively charged particles called electrons there. So the electrons are outside of the nucleus and the protons and neutrons are in the nucleus. Together, all three of those things, protons, neutrons, and electrons, are called subatomic particles. They're in the atom. Okay, so determining the atomic number is different for every different element. So whenever you know what the atomic number is, that defines the element that you have, or the atom. So if you have an atomic number, as in this graphic is 29, we will know that it's copper. The atomic number is the number of protons, always. So in this case, we have 29 protons. The atomic number is always a whole number. The atomic mass is the sum of the protons and neutrons. So we have in this graphic, we have the atomic number is 29, and we have the atomic mass is 63.5. And the atomic number is going to be represented as a decimal because sometimes you have multiple different versions of your atom. You can have different masses. So what is being represented is an average of all those masses. When you're trying to determine the number of neutrons, in chemistry, we have you round the mass to a whole number, so in this case it would be 64. And remember, we said that the atomic number is 29, and so a copper would have 29 would be taken out of the 64, and you would be able to figure out that you then have 35 neutrons. Okay, so the mass is all related to the protons and the neutrons, and if our mass is 64, we take 64 minus 29, and that tells me how many neutrons I have. Alright, so parts in an atom. The nucleus has both protons and neutrons in it. Protons are positive and they have mass. Neutrons are neutral, they have no charge, and they have a mass. Electrons orbit around the nucleus and they are negatively charged and they have no mass. Okay, protons and neutrons do not have to be equal. So in our last example where I showed you the graphic of the copper here, the copper has 29 protons, and we said the mass is 64, and if you take the 29 out of the 64, so 64 minus 29, you get 35 neutrons. That is not equal to the number of protons, and that's fine. Alright, so that's an example. Here's another two examples. So on the left we have the Bohr model for carbon, and that 12 up in the air is telling me the mass of that carbon. So as a result, we know carbon always has the atomic number of 6, and that tells me how many protons. If I pick up an element that has 6 protons, I'll know that it's carbon. So because it's neutral, it's an atom, we know that 6 protons will equal 6 electrons. And the mass is 12, so 12 minus the 6 protons gets me 6 neutrons. Okay, in a Bohr model, we put the protons and neutrons in the center, and you can label them as the dots there, or some people will just write the 6p in the middle and 6n in the middle. Then placing the electrons around the outside of your center, you're going to have in the first shell you'll have 2 electrons, and then the next shell can have up to 8, but in this case we only need 6 electrons, so we would have 4 more, so we'd put the 4 electrons around it. On the right is oxygen, and it's a mass of 16 as indicated in the 16O there. So oxygen always has 8 protons, so we'll have 8 protons in the center, and 16 minus 8 gets me 8, so the other 8 are neutrons. My protons and electrons should be equal because it's an atom, and I will have 8 electrons outside of my nucleus. there's 2 in the first shell and then another 6 after that. So the math is usually pretty simple, but you will have to pay attention and use the periodic table and practice.